So you are welcome to the second class, Module 1, Unit 1B, where we are going to study other degree linear and non-linear differential equations. Here we are only looking for means to classify, to describe differential equations. So we shall start with the order of differential equations. The order of a differential equation is the order of the highest order derivative appearing in the problem, in the differential equation. If you look at this, we see now that I underline highest order derivative. That is the key word there. Because the first thing we need to do is that we look for the highest derivative in the differential equation. Then the number, the power of it is what we refer to as the order. For example, let's consider this. In this case, we call this one second order. Why? Because the highest derivative is second. And you can see now that we have y, which is the unknown variable, unknown function we are looking for. We have x squared. We cannot pick all of them because they are not derivative. Example number 2. Let's look at this one again. You notice that here, we have it to be first order, but there's a square on it. That is why we see dy dx squared. And because of that, you can see now that the highest derivative here is what is 1. And with that, we can say that the problem is first order ordinary differential equation. Example 3. In this case now, we have the problem on the screen. In this case, you notice that the highest derivative here is what is 3. And because the highest derivative is 3, and you can see now that the second one, we have second derivative, we have first derivative, and we even have first derivative in the bracket raised to power 3 is equals to 0. And because the highest derivative here was 3, we're going to call this one third order ordinary differential equation. Now let's look at example 4. Example 4 here, we have fourth derivative, and in this case, the unknown function we are looking for is y. And if you look at it again, you notice that we have plus x plus y, then second derivative again. And if I should ask you what is the highest derivative, you see that the highest derivative is 4. So definitely we are going to call this one fourth order ordinary differential equation. Example 5. If you look at this problem very well, you will notice that u is the dependent variable a, and x and y, they are the independent variables. So what does that mean? It means that we are actually dealing with partial differential equation. Now let's take a look at the highest derivative. The highest derivative here is what is 2. And in that case, we are going to refer to this problem as second order partial differential equation. Now let's proceed to example 6. In this case, again, we can see now that the unknown variable we are looking for, the unknown function, which is the dependent variable, is u. And what about the independent variable? We have the independent variable to be x and y. And then another thing we should look at is that we have another dependent variable, which is called v. So in this problem now, we have u and v to be the dependent variable, and we have x and y to be the independent variable. So how do I describe this problem here that is example 6? I can call this one fourth order partial differential equation. The next thing we are going to consider now is called the degree. This time around, we want to go extra miles to describe differential equations, not only using the order, we also want to use the degree. Don't forget that what we're trying to do now is that whenever we see any differential equation, we must be able to describe the problem. So I've explained to you using five examples on how to use the order. This time around now, we want to add the concept of degree to further see how to describe differential equation. Now look at the definition on the screen now. The degree of a differential equation is the highest exponent of the highest order derivative. If you look at this area, you notice that I underline the words highest order derivative. In this case, the first thing we need to do is that we look for the highest derivative in the problem. But before we look for the highest derivative, we need to first of all take a look at radicals and fractional powers. Whenever we have radicals in the problem, we need to first of all simplify and remove the radical. In fact, if at all we have fractional, we need to remove them. That is thereafter that we can now say that we know the degree. Let's consider example 1. In this case now, you notice that you've seen this problem before, which we've classified as second order. But this time around now, you notice that the highest derivative is what? Is second. And what is the power of the second of the highest derivative? The power is what? Is 1. So we can call this one second order first degree ordinary differential equation. Example number 2. Here we have the problem here to be partial differential equation where z is the dependent variable and x and y are the independent variables. So what is this now? You can see now this one is what is second order first degree. Why do I call it first degree? If you look at the second derivative of z with respect to x, you see that the power is what? Is 1. If you look at the second derivative of z with respect to y, the power is what? Is 1. So because of that, we can now conclude that this problem here is actually second order first degree partial differential equation. Example 3. Look at this problem that we've described before as first order. Now, let's now further describe the problem by reference to its degree. Now, look at this problem here. You will notice that the derivative is what? Is 1. And what is the power of the derivative? The power is what? Is 2. So because of that, we're going to call this one first order second degree. Example 4. If you see this one again, you notice that we've described this one as well before. We only use the order the other time, but this time around now, we want to add the concept of degree to it now. What is the highest derivative? The highest derivative is what? Is third. So we have the third derivative. So looking at this now, we can see now that what is the power of the highest derivative? The power is what? Is 2. So which means that example 4 is actually third order second degree ordinary differential equation. Why do I call it ordinary? I have just only one dependent variable and one independent variable. Example 5. Here we have a problem here and we are asked to describe this differential equation. We all know that it's actually ordinary differential equation, but we don't know the order, we don't know the degree. So how do we go about it now? The first thing now is that we can see now that we have square root a. So like I've said in the definition, we need to first of all remove the square root. So how do we go about it? We need to square both sides. So by the time we square both sides, you will see now that the squaring of both sides will give us r to be r squared, and at the same time the square we take care of the square root. So we now have this. So how do we now classify this now? We can now say that this is actually what? First order third degree. How do I know that it's first order? You can see now that we only have one derivative here. You know, all the derivatives, they are single, they are 1. And what about the degree? You will notice that here in this bracket here, we have the y dx raised to power 3. So that is the power of the highest derivative, which we are going to call 3. So this problem now is first order third degree ordinary differential equation. Example 6 on the degree of differential equations. Now we have another problem here now. If you look at this one very well, you notice that we have a divided by the y dx. Do you know that a divided by the y dx is still the same thing as a multiplied by the y dx raised to power minus 1? So in that case, we need to first of all address that of minus 1. How do we do about it? We can actually multiply both sides by the y dx, so that there will not be anything like raised to power minus 1 again. So by the time you multiply both sides by the y dx, we notice that y will now be a multiplier of the y dx, x the y dx will multiply the y dx, and by the time you multiply a over the y dx by the y dx, a it will go, then it will remain a, then we have 5 the y dx. So which means that we've been able to remove that. So how do we clarify? We can now call this one to be what? First order second degree. Why do I call it second degree? You notice that here I'm having the y dx times the y dx, and by the time you have the y dx times the y dx, that means that you are having the y dx squared. That is why you come up with second degree ordinary differential equation. The next thing we're going to consider now is called linear and non-linear. Before I proceed, let me first of all give you the definition. You know, this definition is applicable to either ordinary or partial differential equation. You know, but one thing that is important is that the dependent variable and its derivative, they must occur to the degree only, not as higher powers of products. Let me say that one again. You know, the first thing is this: we need to first of all discover the dependent variable. When we discover the dependent variable, then we now look at it that if it's multiplying the derivative, then if that is the case, then we know that we are talking about nonlinear.
But by the time they are not multiplying themselves, then that means that we are actually talking about linear. That is why if you look at the definition, we say that the dependent variable and its derivative, they occur to the degree only, not as higher powers of products. That is the definition we have for that. And I will still explain this one to you better, but just bear it in mind that before you will be able to classify a differential equation to either linear or non-linear, the first thing you must do is that you look for the dependent variable. Then you now look at it again. Is the dependent variable multiplying its derivative? If yes, then that is non-linear. But if no, then that means that we are talking about linear. In fact, we can even go ahead and say that the coefficients of a linear equation are therefore either constant or function of the independent variable or the variables. That is in the case of partial. In the case of partial, we have independent variables. So in that case, we call it to be non-linear. But the most important thing before you be able to classify any differential equation is to first of all look for the dependent and independent variable. So wherever you see the dependent variable multiplying itself or multiplying the derivative, definitely that is non-linear. Let's consider example 1. Example 1a, is it linear or non-linear? Before we be able to answer that question, let's also look for the dependent variable. In this case, the dependent variable is y. Is there anywhere we are seeing the dependent variable multiplying either itself or multiplying the derivative? No. So that means that we are actually talking about second order, first degree, linear ordinary differential equation. Let's go to example 2. Example 2 here, we are talking about dependent variable is what is y. And we have its derivative multiplying itself. Even that is why we refer to this example 2 as second degree. So you cannot say now that if it's second degree, then definitely it's going to be non-linear, because we can see now that the derivative, they're already multiplying themselves. So this one is now called example 2 is first order, second degree, the non-linear ordinary differential equation. I don't think I need to explain again why I call it ordinary again, because you can see that here we have one dependent and one independent. Example 3. Example 3 here is actually second order, first degree, and linear. Why do I call it linear? There is no place in example 3 where the dependent variable is multiplying itself or where the dependent variable is multiplying its derivative. So we're going to call it linear partial differential equation. Example 4. Example 4 here is third order. We all know the reason why it's third order, because the highest derivative here is 3. And what is the power of the highest derivative? Is 2. So definitely this is called second degree. Now, is it linear or non-linear? It is non-linear, because you can see now that in this case, we are having the derivative multiplying themselves. The third derivative is multiplying itself, while the first derivative is multiplying itself 3 times. So that is why we're going to call this one non-linear. In fact, based on all these things I've been explaining to you, you can see now that it's very rare before you can see a problem that is of higher degree, of degree more than 2, that is linear. Definitely it's not possible, because a problem is said to be of degree, of higher degree, if we can see the product of dependent multiplying itself or multiplying the derivative. So that means that it's not really possible for us to have a problem that is of degree more than 2 that is linear. It's not possible. It can never possible. So immediately you can see it to be of higher degree, definitely it's going to be non-linear. That is one thing about differential equation. Let's go to example 5. Example 5 here is the problem you are familiar with before. I've shown you before. And what is the degree? The degree is what is 3. So we call it third degree. Then is it linear or non-linear? It is non-linear, because you can see now that the y dx is multiplying itself 3 times. So we can have the y dx times the y dx times the y dx. And in that case, you can see now that this one is in agreement with the definition we've presented earlier. So we call this one non-linear. The next thing we are going to consider now is a question. How do I identify first order PDEs? How do I identify first order? This discussion here is very important because it will lead us to the 4 categories of first order PDEs. Most times when we have nonlinear, the nonlinear of PDEs, they can be categorized into 3 other categories. So that is why this part is very important. Now let's proceed now. A first order PDE, usually we call a PDE in 2 independent variables x and y and 1 unknown function which is the dependent variable z. We can write it in form of equation 1 here. If you look at this equation 1 here, we have a function f that is dependent on x and y, which are the independent variables, and z is the dependent variable, and we have the partial derivative of z with respect to x and the partial derivative of z with respect to y equals to 0. That is how to write first order PDE. But there are 3 things we need to notice now. Number 1, the equation above here is just like a mathematical expression, but it contains most important facts. Fact number 1, the independent variable x and y. Fact number 2, it contains the dependent variable z. Fact number 3, it contains the partial derivative of z with respect to x and y. Those are the very important things that we must look for whenever we can identify any first order PDEs. In fact, it is very possible to have more than 1 dependent variables. But before I take you to that aspect, let me first of all show you an example of a first order PDE that is dependent on 3 independent variables. As you can see now, let's consider this. We have u here to be the dependent variable, and we have x, y, and z to be the independent variables. In this case, we're going to call this one first order because here the derivative of each term is actually 1. Let's consider another example. In this case now, you will see now that dependent variables are 3. We have u, v, and w to be the dependent variables, and we have x, y, and z to be the independent variables. This particular equation is very important in fluid mechanics. It is called continuity equation. So let's proceed now. I'm going to show you 4 examples now. As you can see now, we have 4 examples on the screen, and these 4 examples here, they are telling us about the 4 categories of first order partial differential equations. I'm telling you now that all of them, they are not the same. They are not the same. They are different first order partial differential equations, which we are going to consider in our next slide. The last aspect now is now to present the 4 categories of first order partial differential equations to you. Number 1 is linear. As you can see on the screen now, we have partial derivative of z with respect to x plus partial derivative of z with respect to y. And as you can see in that case, there is no multiplication there. We are not having any situation whereby the dependent variable is multiplying either itself or the derivative. So we call this one linear first order partial differential equation. Semi-linear first order is the next thing we're going to consider now. If you look at this problem very well, you will notice that the first part is linear, while the second part is non-linear. If you look at this very well closely, you will notice that if you look at the first part here, that is partial derivative of z with respect to x plus partial derivative of z with respect to y, they are linear. But if you look at the other side, you will notice that z raised to power 3, it's typically non-linear. Exactly, because we're having z times z times z, that makes it to be what? To be non-linear. So in that case, we're going to call this one semi-linear because one part is linear while the other part is non-linear. Quasi-linear. In this case of quasi-linear, what we're having here is exactly dependent variable multiplying the derivative. And in this case, we only have it one side. If you have something like that, double sides, or perhaps we can say it's double-sided, then we're going to call it non-linear. But in this case now, we have it to be what? Z partial x, which is actually make this problem to be non-linear, to be quasi-linear. Are we together now? So this is quasi-linear first order partial differential equation. Then the last one here is nonlinear. So in this case, we're having the derivative of z with respect to y multiplied by the derivative of z with respect to x, and that makes it to be what? To be non-linear. Now you can now see in this case now that whenever we are talking about partial differential equation, the nonlinearity can be divided into three categories.